Good morning. I will be going over your trig final exam review for questions 1 through 10. Let's get started. So question number 1 is asking you to find the length of side PR. I've highlighted side PR, which is our hypotenuse. You want to remember to always label your triangle either opposite, adjacent, and hypotenuse. And all three sides are in reference to the reference angle. And this problem is 33. So since we want to find side PR, we're going to do opposite over hypotenuse, which is sine. So as you're working, you should have your notes out as well. So sine of 33 equals 16 over x. And we're going to solve for x. So we're going to multiply x on both sides. We're going to divide by sine of 33. Then we get x by itself. So x equals 16 over sine of 33. And you're going to put it in the calculator as is. 16 divided by sine of 33, which is x equals 29.38. Question number 2, you're also looking for a side length. This time it's BC. Again, you want to label your sides in reference to your reference angle. This time it's 62. You want to remember your reference angle is never your 90-degree angle. All right, so 62. So BC is across or opposite 62, and they give you the hypotenuse. So that is also sine. But the sine of 62 equals BC. That's my unknown. That's the side I'm looking for. Divided by 10. So you can either label it BC or you could put X. It doesn't matter. All right. So you're going to multiply 10 on both sides. And then you're going to get BC equals 10 times sine of 62. And BC equals 8.83. So just probably a shortcut or a hint. Anytime your unknown is in the numerator, you're going to multiply the number and the trig and the degree. If your numerator has a number placed there, you're going to divide the number divided by the trig function. That's just a little shortcut. All right, let's look at questions 3 and 4. All right, this time we're solving for B and C. So those are two side lengths of a right triangle. All right, so as you can see here, I've already labeled my triangle, and my reference angle here is 25. So opposite, adjacent, hypotenuse. Right now I'm looking for side B. Side B is opposite over adjacent, which is tangent. So tangent of 25 equals B over 8. I'm going to multiply both sides by 8. So since my numerator has a variable, then I'm going to multiply 8 times 10 of 25, and B equals 3.78. Next, I'm looking for C. Reference angle is 25. It's adjacent over hypotenuse, which is cosine. So cosine of 25 equals 8 divided by C. Since my numerator is a number, I know I'm going to divide. So, or if mathematically speaking, you're going to multiply both sides by C. You're going to divide by cosine of 25. And you're going to get 8 divided by cosine of 25. And you're going to type it into the calculator as is. And C equals 8.82. All right, next, number 4. So write a similarity statement for the 3 triangles below. Why are the 3 triangles similar? So you have a big triangle, which is pink, a smaller triangle, which is black, and an even smaller triangle, which is blue. So these are my 3 triangles. All right. So remember, when you're setting up your triangles, position matters in reference to your angles. So if I have A, C, B, is similar to my triangle A, D, C, because they both share the right angle. But in the big triangle, the right angle, is C, And then in the black one, your right angle is D. So D is in the middle. This of each C, D, and D all share right angles. All right, so this is how you set up the similarity statement. It's not a statement written out. It's your similarity statement saying that ACB, triangle ACB, is congruent to triangle DADC is similar to BCD. And why is that? By angle-angle similarity. So you want to remember that you only need two angles to prove similarity, or you need that to know that the angles are congruent and the sides are proportional. All right. So if they ask a question on the test about similarity, it's due to angle-angle similarity. All right. Number 5. What is the measure of angle L? Angle L. That means I'm looking for an angle. Angle L, my reference angle is not given, but I've been given 3 sides. When you've been given 3 sides, you can choose which trig function that you're most comfortable using in this problem. So for me, I'm more comfortable using sine. So what is my side opposite? And then what's my hypotenuse? So 13 over 85. Sine of L equals 13 over 85. To undo sine, you use sine inverse. Sine inverse. So it's sine with a -1 at the top. But you don't say sine of -1. You say sine inverse. That will undo sine on this side. All right. So that will get L by itself. So you have sine inverse 13 divided by 85. You will type that into the calculator. Please make sure your calculator is in degree mode so you can get the correct answer. So the degree measure for angle L is 8.89. If they ask you to round it to the nearest degree, it will be 9 degrees. All right. So remember, if you're looking for an angle, you want to do the inverse of whatever trig function you choose. All right. So number 6, same thing. I'm looking for the measure of angle J. Angle J is here. All right. So for me, for this particular problem, I chose to use tangent. So that's opposite over adjacent. So that's tangent of J. We don't know what J is. We don't know what our reference angle is. Equals 4 square roots of 3 divided by 2 square roots of 3. All right, so I did a little math here, so you can go ahead and cancel out square root of 3 divided by square root of 3 and 4 divided by 2. So that leaves me with 2. Okay, so tangent of J equals 2. So remember, what do we do to undo a trig function? You do its inverse, tangent inverse. So do tangent inverse on both sides. So tangent inverse on both sides. So then we get tan inverse of 2, which is 63.4 degrees or 63 degrees. Depending upon if the question asks you to round it to the nearest degree. All right. Number 7. Number 7, you just have to use the Pythagorean theorem. I wrote it here up top. A squared plus b squared equals c squared. We're looking for side length FH. I wrote that in. That wasn't already there. So remember, your hypotenuse is always across from the 90-degree angle. So they giving you the hypotenuse and a side. So I just filled in the blanks. So 5 squared plus b squared, we're not sure what that is quite yet, equals 13 squared. So 25 plus b squared equals 169. That's 13 squared. I'm going to subtract 25 from both sides, which is 144. B squared equals 144. How do you undo a square? You take the square root. So if I take the square root of both sides, I get 12. That is my side length. All right, number 8. Same thing. You've been given your hypotenuse and a side. Remember, A and B It really doesn't matter. The other two sides, what you plug in to, either I could have plugged 10 into A or B. But the hypotenuse is most important. That was given to me. So 10 squared plus B squared equals 14 squared. So I'm going to subtract, square each number, 100, and then 14 squared is 196. I'm going to subtract, I'm sorry, I messed that up. Subtract 100 from 196, and I get 96. All right, so take the square root of each side, and a square root of 96. So you want to remember that you want to find the greatest perfect square. The greatest perfect square is 16 times 6, which gives me 96. Square root of 16 is 4, and the square root of 6 is just the square root of 6. So my final answer is 4 square roots of 6. All right, number 9. In a right triangle, x, y, z, x, and y are complementary angles. Remember, in complementary angles, your angles have to add to 90 degrees. So if sine of x is 8 over 15, what is cosine of y? So I already know that sine of x is 8 over 15, so 8 opposite over hypotenuse. If y is my other angle, then it should equal the same length, which is 8 over 15. So there should be equal. So your complementary angles are always equal to each other, your side lengths. But the angles themselves are always equal to 90, and we're going to see that in number 10. All right. So if they say sine of x is 8 over 15, the other angle, cosine of y, is also equal to 8 over 15. All right. Last question. Fill in the equivalent values. So this is straightforward. If we know that this is 36 and both angles have to equal 90, you just do a 90 minus 36 equals 54. And you're placing it here. 90 minus 45 is 45. 90 minus 72 is 18. And then 90 minus 22 is 68. Now you want to notice that each sine and cosine are always opposite one another. So remember, complementary angles equal 90 degrees. All right. If you have any further questions, please make sure to address them with your teacher. Good luck on your finals and enjoy your break.